Greetings to all viewers. This is Professor Ankit Singh. We'll now move to the next topic, that is analysis and the presentation of the spot speeds. So till now we have discussed what are the methods to gather data regarding the spot speeds. Now we'll have a look at the presentation of these spot speeds. So the different types include graphical presentation of spot speed data, under which we have frequency histogram, frequency distribution curve, and cumulative frequency distribution curve. So using these three types of graphs, we represent the spot speeds. For the graphical representation of data of spot speed studies, it is possible to obtain the following results or values. Okay, so from the graphs we can obtain these values. Speed to check the geometric design, that is 98th percentile speed. Okay, this is from cumulative distribution curve. Okay, upper speed limit for regulation, 85th percentile speed, this is also from cumulative distribution curve, and lower speed limit for regulation, 15th percentile speed, median speed, 50th percentile speed, and modal speed value corresponding to the maximum peak of the normal distribution curve. Okay, here the first one, that is the 98th percentile speed, this speed is also known as the design speed. Then for the upper limit we use 85th percentile speed, for the lower limit we use 15th percentile speed. The median speed is 50th percentile speed, and the modal speed is the speed which has the maximum frequency. Okay, we can find out all these speeds using a CD curve, or the cumulative frequency distribution curve. Now the second type of representation or presentation is using statistical analysis of spot speed studies. The statistics used generally describes two important characteristics of the distribution: measure of central tendency, which defines the approximate middle or center of the distribution, mean, mode, median, and pace; and measure of dispersion, which defines the extent to which the data spreads around the center using standard deviation and variance. Okay, now here you can see a tabular representation of the data. The speed of the lower group is given in kmph, 10, 15, 20, 25, and speed for the upper group is given 14.9, 19.9, 24.9 kmph, okay, etc. So the speed group would be 10 to 49.9, second 15 to 19.9. so you can write it down here. Now the mid values for this group range would be, what is the mid value between 10 and 14.9? It is 12.45. Similarly 17.45, 22.45, and so on. Okay, now what we recorded using the spot speed during the spot speed studies are the numbers of vehicles which were traveling at these speeds. So at this mid speed there is 0 vehicle, at this speed there is 6, 8, and so on, etc. Okay, now what we can do is we can find out the percentage of observations. Okay, so 0 out of, what are the total observations? 300. So 0 divided by 300 into 100 is 0. 6 divided by 300, okay, into 100 is 2. Similarly we can do it for all the values, and this is the percentage of the observations along these speed ranges. Okay, now we need cumulative distribution, so we just need to do a cumulative form a cumulative column for these values. First would be the same, second would be 0 plus 2, it is 2, Third is 2 plus 2.67, it is 4.67. Then 4.67 plus 9.67, it is 14.33. Similarly, you do it for all these values. So we have this tabular representation. Now using these values, these columns, what we'll do is we'll represent the data using graphs. First one is frequency histogram. Here along x-axis we have the speed kmph in kmph. Okay, these are the mid values, this column. Okay, and we have number of observations along the y-axis this here. So for 12.45 it is 0, for 17.45 it is 2. Okay, so 17.45 the value is 2 somewhere here. Okay, similarly you can plot this graph. Okay, so this is the frequency histogram presentation of the spot speeds. Okay, next type of presentation is using frequency distribution curve. Now here you have the same mid speeds in kmph along the x-axis and number of observations along y-axis, but here instead of using these bars, we do not use any bars, we just mark the points and then we join these points, each of these points. So we have this curve. Okay, so from this curve we can find out the modal speed. So the peak of this curve is at this point. Okay, so from this point when you drop a perpendicular downwards, you will have this speed, that is 44.45 kmph. This is nothing but the modal speed. And we know what is pace. Pace is the range of 16 kmph. Okay, so this range is of a total 16 units from here. So what we do is from this line we take 8 units to the left side and 8 units to the right side, and then we drop 2 perpendiculars over here. So this would be our pace range. Okay, and this range would vary from speed here to here. So these values would be around 34 kmph to something around 50 kmph. Okay, so this is the pace. Next presentation is using the cumulative frequency distribution curve. Now here what we do is along x-axis we have the same thing, that is mid speed, but along the y-axis we have the cumulative values. We have these values. Okay, so after plotting this, as I had discussed earlier on, the 98th percentile speed, here 98th percentile would be the geometric design or the design speed, 85th would be our upper limit, 15th would be lower limit, 50th would be median speed. Okay, so now here you can observe we have the values here. So from here, once you have plotted this graph, okay, this curve, you have plotted this curve, now you can find out what is the design speed. You find out 98 over here and then extend the horizontal line. At the point when it cuts the curve, you need to drop a perpendicular. So this speed is the design speed, okay, or the safe speed to check geometric design. Then 85th percentile, you find out 85 over here and extend a horizontal line. It cuts the curve at a point, you drop a perpendicular from that point. This speed is nothing but the upper speed limit. Similarly you do for 50, this is the median speed, and when you do it for 15, it is the lower speed limit. Okay, so using this cumulative frequency distribution curve we can find out the design speed, upper speed limit, lower speed limit, and the median speed. Now this is all for spot speed studies. Now there is another concept which is known as speed and delay studies. Here what we try to find out is what would be the speed of the vehicles taking delay into consideration. Okay, so for this there are few methods which are moving observer method or floating car technique, license plate method or registration number method, elevated observer method, interview method and photographic method. So here in this first method, that is moving observer method, the surveyor would himself be placed in a car, okay, which is the survey vehicle, and he will travel along the road. Okay, now assuming that we are doing this survey from point A to point B. Okay, so there is a road connecting point A and point B, and the surveyor is placed in a car and he himself travels from point A to point B. Now what he will be doing is he will be recording the time that was taken for him to travel from point A to point B, what was the delay time, what was the running time, how many vehicles did he overtake and how many vehicles overtook his survey car. Okay, so all these data he will be recording. Now this survey that he will be conducting is known as speed and delay study. Okay, this is one method used for speed and delay studies, where we find out the speed of the vehicle which moves in the test area and what are the delays which occur, what are the reasons for the delay. Okay, so now this was the first method. The second method is license plate method, which is similar to the method that we use for origin and destination studies, where the surveyors are placed at the cordon line of the study area. Okay, so we have a study area and we have the boundary line. The surveyors would be placed at the boundary lines of the roads which enter and exit from the study area, and the surveyors would record the license plate number of the entering vehicle and also the time of entry, and when the vehicle would leave that study area, again the surveyor would record the license plate number and the time of exit. So using this we can find out what was the total time that this vehicle was available inside the study area. Here the disadvantage is we do not have any idea about the type of delay, okay, inside the study area. The next method is elevated observer method, in which the observer or the surveyor is placed at a point of high elevation. Okay, he might be placed at a building tower at a height and he observes the vehicles which are moving inside the study area from that height. Okay, so he can observe from for the vehicles moving from point A to point B, that what are the delays, why are the delays being caused, what is the delay time, what is the running time. Okay, all this is observed from a elevated point. The next is the interview method, wherein the surveyor would interview the drivers and ask them about their delays in that study area. Okay, and the last one is the photographic or the videographic method, where either the time-lapse photography is being used or videographic being used in order to find out the speed and delays. Now this data can be presented in either time counter maps, bar charts, speed profiles, frequency distribution curves, speed zone maps or delay zone maps. These are a few ways of representing this data. Now how do we analyze this data? First step was the estimation of traffic flow. We find out what is the traffic flow in that area. Then we find out what is the journey time. Okay, what is the delay time, the running time and the mean journey time. Okay, then we find out what is the journey speed the mean journey speed and the running speed. So this is how we do the analysis for this type of study. Okay, we'll move to the next method in my next class. Thank you.